Kia ora Year 12 and Year 11. This video is going to go through 4 examples from the homework on page 23, looking at how we find the equation of the tangent to the curve. Because I've done this in class, I'm not going to do graphs for each example, but I suggest that you get out your Casio graphics calculator, and as we go, you draw the graph of the curve so that you can visualize what we're trying to find. So I'm going to do a little graph for this first one, because I can do that by hand roughly. So as usual, this should be called maths with bad graphs, but there you go. So there's y equals x squared, and what we're trying to find is at the point 3, 9, so we'll make this 3 and this 9, what's the equation of the tangent to the curve, right? So we're looking for the equation of a straight line. Now the way we get the equation of a straight line from coordinate geometry, everyone's favourite topic, we have this equation. So we have to find 3 things to chuck into that equation. And we've got the first 2. We've got x1 and y1. So that's my point. We know that the line goes through that point there. The last thing we need is the gradient at that point. And to find that, we've got to differentiate. So let's do that now. So dy by dx is equal to 2x. And I can also write that as f dash of x. We want to evaluate that gradient function when x is 3. So we chuck 3 into the gradient function, and we get f dash of 3 is equal to 2 times 3, which is 6. And that is going to be m in my equation of a tangent. So all I've got to do now is substitute that into this equation. So we've done the hard work. So y minus 9 is equal to 6 times x minus 3. Expanding that out, we get y minus 9 is 6x minus 18. So we get y equals 6x minus 9. So that's that one done. All right, 3 left to do. The ones I'm going to do, questions 1, 2, 4, and 9. And I should have said before, big thank you to Daniel F. for asking for this video. I am really happy to do more, but you've got to tell me what you want. Otherwise, I will just I do whatever videos you guys ask for, basically. Okay, so this is question 2. Question 2 looks like this. This time my functions are cubic, and I want to find the equation of the tangent at the point 1, 9. So we start off by differentiating. F dash of x is equal to 6x squared plus 7, and now I want to find the gradient when x is equal to 1. So f dash of 1 is equal to 6 times 1 squared plus 7, which gives me 13. Now, chuck it in here, y minus y1 is equal to m times x minus x1, and we've got all of the information we need. We've got y minus 9 is equal to 13 times x minus 1. That gives me y minus 9 is equal to 13x minus 13. So y is equal to 13x minus 4. Right, we like this. This is in the form of y equals mx plus c. Okay, 2 left. Right, question 4. We've got f dash of x is equal to that. So that's a parabola, and the point we're asked for is negative 1, 9. So f dash of x is equal to negative 3 plus 2x. We're interested in the gradient when x is negative 1. F dash of negative 1 equals negative 3 minus 2, which is negative 5. So that's m. Y minus y1 is equal to m times x minus x1. So y, take away 9, is equal to negative 5 times x minus negative 1. Y minus 9. So I've got here, this is a plus and this is a negative, so that's minus 5. So the final answer is y equals negative 5x minus 5 plus 9. So that's going to be plus 4. Right, the last one, it's got a wee fraction in it, that's good. So we're going to rewrite my function as 10 minus a half x squared, and I'm asked to find the gradient at the point 6, negative 8. So differentiating gives me, well, this is a constant, so its slope is 0. And for this bit, I'm going to have negative, I'll do this slowly, negative a half times 2x. So that works out to be just negative x. Evaluating that when x is equal to 6 gives me negative 6. So y minus y1 is equal to m times x minus x1. Y minus negative 8 is equal to negative 6 times x minus 6. Y plus 8 is negative 6x plus 36, giving me my final answer for the equation of the tangent as y equals negative 6x plus 28. So there you go. So there's 4 that are very, very similar. Just looking at a screenshot of that page, these ones are all straightforward because you're given the whole point, right? And we looked at this in class. You're given the x and you're given the y. If you're not given the y value, then you have to go and figure it out. And the way to figure it out is to think that this has got to be the y value on the curve. So you have to substitute in 6 to get the negative 8. So here, if I hadn't been given the negative 8, I would do this. F of 6 is equal to 10 minus 6 squared on 2, which is 10 minus 18, and that's where the negative 8 came from. Okay, so don't get that confused with looking at what we chuck into the gradient function, because they're very different things. Okay, have fun and try and do the rest of that page, and if you've got any problems, just send me an email and I will try and do a video for you. Thanks for watching.